Well, hello and welcome to today's Tech Talk. Today we'll talk about how to automate threat mitigation using AWS WAF and Amazon GuardDuty. My name is Alex Tomic. I'm an AWS Solutions Architect. And with me is Cameron Worrell. He is also a Solutions Architect. We are both based in Atlanta, Georgia. We often go out and talk to customers about how to improve their security posture, and actually automating these mitigations is one of the big important points that we talk about. A couple of notes about today. All the copies of the slides will be provided to webinar attendees. Also, if you have any questions, please feel free to post them during the webinar. We have a moderator standing by who will help to answer the questions. Also, if we don't get to your questions during today's webinar, please feel free to use AWS Forms to post those questions at any time. Here's the agenda for today. First, we'll start with a brief overview of AWS security services. Then we'll actually jump into a deeper dive on two specific services, AWS Web Application Firewall, or WAF, and also Amazon GuardDuty. After that, Cameron will take over and talk about some general patterns around the response automation. He will then demonstrate a very specific example of those automation patterns, and that demonstration is actually based on a blog post that we recently published. So we'll point you out to that blog post. After the demo, we'll come back to the presentations, and we'll provide you with some of the calls to action to improve the security posture in your own AWS account, and also give you links to resources that we have mentioned during the webinar. So the reason that Cameron and I are so excited to talk about this particular topic, about automating security and security mitigations, is that after you actually use AWS platform for a while, you can notice that you can take your AWS security to a whole new level. You can really keep your development teams innovating rapidly, adding features, adding new services to your products, and while they're staying completely secure and operating within secure, compliant guardrails. So how do we actually achieve that high velocity while staying compliant and staying secure? Well, the key to that is automation, and it is the magic ingredient. And today we'll talk about specific options how to implement automation. But before we can do that, we'll cover some of the basic AWS services that make that possible. At AWS, security is job zero. Security is our top priority above all else. Due to the scale of the platform and that high priority that we place on security, we're able to invest in development of security features and security services at a level that's really hard to match by any individual's organization's IT department or an organization's security department. So as a result of the heavy investment and innovation, we have developed a robust suite of security services, and those are the services that our customers are using today to improve their security posture in AWS. The whole suite of services is divided into 5 categories that you see on the screen here, and below that we put some examples of the services, but they're definitely not an exhaustive list. Before you can interact with AWS, it is important to actually prove who or what you are, and before you can actually make any individual AWS API call. If you have ever logged into AWS console, for example, you have interacted with AWS IAM, or Identity and Access Management Service, behind the scenes. If you have worked with some of the large organizations, or you may have used some of our other services that cater to large complex organizations. On next one, we have a suite of services we call Detective Control. And under this, we actually start to record events and behavior that's occurring inside of your AWS accounts and your applications. An example of that is Amazon GuardDuty, and we'll talk in a lot more detail about that service shortly. Under Infrastructure Services, we have a lot of services that we use for preventive control. These are services that help block traffic or block unwanted behavior. An example of that is AWS WAF, or Web Application Firewall, and we'll talk a lot more detail about that in a second. Next suite of services is data protection, and this is all about helping you encrypt data at rest, encrypt data in flight, as well as analyze different access patterns for the sensitive data that you stored in AWS. Finally, under incident response, this is the suite of services that helps us kind of pull together, integrate, and automate all of the other services that we talked about so far. And in today's demo, we will use AWS Lambda to integrate GuardDuty and AWS WAF. And the first service that we'll discuss today and kind of do a deep dive into is AWS WAF, or Web Application Firewall. So AWS WAF is a service that helps to protect web applications from attacks such as SQL injection, cross-site scripting, and similar attacks. It gives you a full visibility into the web requests that are coming to your web application, and then you can create rules that inspect that traffic and hopefully only allow desired traffic to pass through and block any malicious requests. You can then apply those rules once you create them, apply them into production, and you can monitor them actively in real time, and you can fine-tune the rules as you see them, observe them in behavior. One of the big advantages of AWS WAF is that it's very DevOps friendly. You can use its API-driven configuration. You can utilize CLI or SDKs to really fully configure and operate the service. AWS WAF is available for integration with Amazon CloudFront, which is our content distribution network, or CDN, that's operating out of 120 plus edge locations globally. It is also available inside of AWS regions, and you can deploy it inside your VPCs while integrating it with Application Load Balancer, or ALB. You can integrate WAF with both public-facing and internally-facing ALBs, and you can see how you can, with this approach, you can build a multi-layered protection for your data. You can start at the edge, then move to public-facing, then internally-facing ALBs, to different layers of your application inside of the VPC. Here's an example of how we can build a rule for AWS WAF. This is looking at the AWS console, and one of the big concepts inside of the AWS WAF is something we call an WAF IP set. And in this particular case, we're looking at a few IP ranges that belong to an IP set we call Seattle office. Then we can combine that WAF IP set with another condition that we call, in this case, a string match. So we're matching up to a URL pattern. In this case, the URL pattern matches an administrator login page for an application. You can see now how we can combine these conditions into a single rule that basically allows employees in our fictional company's Seattle office to log into a specific web application. In this particular case, we're using a WAF IP set as a whitelist, but note that in the demo today, we'll actually change that around, and we're going to use that WAF IP set as a blacklist, meaning we will be actually blocking the traffic that's coming from a particular set of IP addresses. Here's a screenshot of AWS WAF in action. We are kind of, in this case, observing real-time traffic as it's passing through. We are then matching it up to different rules and triggering those rules. And you can see the kind of statistics on the screen there. Another service that we'll dive into today is Amazon GuardDuty. And this is for intelligent threat detection service. With Amazon GuardDuty, you can enable the service in one or multiple accounts. And as soon as you enable the account, it's going to start to continuously analyze behaviors inside of those accounts and it will then start applying intelligent detection, including some AI ML techniques. And then after that, it will issue what we call GuardDuty findings or alerts that are coming out of it. The feedback that we get from our customers is that GuardDuty provides a really good signal-to-noise ratio, meaning very few false positives, and just about every alert that comes out is highly actionable. And we'll dive into more detail why that is. Here are some of the types of attacks that GuardDuty will detect. So GuardDuty is designed to really cover what we call a full kill chain, meaning it will look for everything from the initial recon phases to installing remote access tools, installing backdoors, exfiltrating data, but it will also look for AWS or cloud-specific attacks, such as the account compromise or compromised account credentials. But these are some of the examples. There's actually a lot more different types of findings that GuardDuty can detect. So let's look at behind the scenes how GuardDuty actually does its detections, how it can actually perform its work. So first step is you enable the GuardDuty, and we'll give you a screenshot of that, but it's really as simple as clicking a single button to enable it. And then as soon as you enable GuardDuty with a simple one click, it begins to ingest telemetry from 3 different data sources. VPC flow logs ingest data from all the network ENIs or network cards inside of all the VPCs inside of your AWS accounts. So it will look for data such as IP addresses, ports, protocols, amount of data being transferred. Next data source that we'll look at is DNS logs, and these are logs attached to DNS resolvers inside of your VPCs. And you can imagine there you can look for items such as potential lookups to Bitcoin mining, for example. Then the next set of data that it looks at is CloudTrail events. CloudTrail is one of our fundamental security services for auditing activity in your AWS accounts, and it records AWS API calls being made against your accounts. So GuardDuty will then correlate all this data together, and it will correlate that against integrated threat intel, and these threat intelligence sources include Amazon's own threat intelligence, that ones that we built, as well as certain third-party data sources. It will look at potential behavior for static signatures of bad behavior, such as, in our case, we'll actually demonstrate the SSH brute force attack, for example. But GuardDuty will also use AI and machine learning techniques to baseline the behavior in your AWS account. And it will then look for any instances of behavior that break that baseline and issue an alert for that. Once GuardDuty has detected an anomalous behavior, it will issue what we call a GuardDuty finding. And we'll jump into a lot more detail here to describe what the finding looks like. Here is a AWS console view of Amazon GuardDuty. Inside of it, you see a listing of different findings that GuardDuty has detected. And over on the right-hand side, you see details of a specific finding. Note also how the findings are classified by different severity level, and those are also built into the different types of findings we have. And we'll jump into the next screen to kind of detect to look at in more depth in a specific finding. All right, so in this case, GuardDuty has identified an EC2 instance that's performing outbound port scans. And here is in the console view, so it's actually giving us a lot of detail about different characteristics of an EC2 instance that's performing an outbound port scan. Now, an outbound port scan is an indicator that this instance has been compromised, but it's potentially running malware or somebody's remotely controlling it. And you have details such as EC2 instance ID, its IP address, the time that the behavior occurred, and a lot more other details that you can look into. If you are interacting with GuardDuty using our CLI or SDKs, basically using our API calls against GuardDuty, you can extract the GuardDuty findings in a JSON format. And this is very useful for scripting and coding because you can actually programmatically extract different fields. And these are basically looking at the exact same data that we looked at in the console, but it's actually coded in a JSON format. One of the features of GuardDuty that we'll utilize today, and you see it in a demo, is that GuardDuty findings are posted in a CloudWatch event bus. And they're actually posted in a JSON format. In our demo, we'll actually configure a CloudWatch event rule to trigger Lambda functions, which will then ingest the data and take remediation actions. And at this point, I'll let Cameron take over and kind of walk through the response automation patterns.
All right, thanks, Alex. My name is Cameron Worrell, and I'm also a solutions architect here at AWS. And I'm going to kind of carry on with the presentation and dive into the patterns and do a demo of a particular solution with a threat mitigation and automation using WAF and GuardDuty. And so first thing is, just want to talk at a high level about some of the common patterns in the flow that you will typically follow in this type of solution. So you start off with event sources. And so the event sources can be many different things. And this is by no means a comprehensive list. But as you can see, you have sources such as CloudTrail, which Alex mentioned. You also have CloudWatch events, which we're going to talk a little bit more about. AWS config, and other sources such as VPC flow logs, and it may be your specific application logs that you use within your own environment. And so once you have your data sources and your logging, that will actually flow into your detection mechanisms. And so this can be a number of different techniques that you can use, such as signature matching, behavior heuristics, all the way up and through machine learning. And actually GuardDuty takes care of a lot of this for you. And so GuardDuty has built-in detections that leverages these techniques without you having to worry about managing those elements individually. It's included in the service. And then finally, once you have your event or your detections, then you can actually trigger remediation. And so this could be a number of different things. So this might be something as simple as notifying an administrator or your security team or your operations team, or it could be something more sophisticated, such as what we're going to show you in this presentation, where you can actually trigger some type of programmatic action that will go ahead and remediate that finding for you. And so to that end, we want to dive deeper into the specific particular pattern that we're going to touch on today, which is automating a response by using GuardDuty, CloudWatch events, and Lambda, and then tying that into ACLs on AWS WAF, as well as VPC network access control lists. So moving from the left, as you can see, and kind of just as in the previous slide, we have our event source, which in this case, it's the logging that comes off of GuardDuty, that JSON object that Alex spoke about a moment ago. That actually is going to come into CloudWatch events. Those events are a near real-time stream of the activity coming off of various services. It can tie into many services, and then it can actually trigger a target action through CloudWatch events. And so in this case, we're going to actually fire a Lambda off. And then finally, we're going to take that action from the Lambda, and that's going to complete our remediation or our mitigation, which is essentially sending a notification as well as updating an AWS WAF, ACL, and a VPC network access control list. All right, so at this point, we're going to dive into the demo and actually show you a specific solution in action. And so the way this solution that we're going to demonstrate works is similar to what we've covered. We have basically the steps outlined here in this diagram. You can see that we have GuardDuty, of course, using CloudWatch events to trigger the Lambda. In this case, we're also using DynamoDB to store some state information, which has basically some information we use in the solution that I'll talk about in a moment. But let me go ahead and share my screen with you. And so the first thing I want to highlight is that we've made this solution available as a publicly available blog post. And so if this is something that you can use to go through, and we actually, in this blog post, will outline the solution. We walk through it step by step. And then as you get into it, you'll see that we provide a link that actually you can use to deploy this solution in your environment. And so when you use this link, it's actually going to launch a CloudFormation stack. And that CloudFormation stack is a template that we've made available, and you can simply click through that. And so when you use the blog to launch this, you'll be presented with a screen in CloudFormation where you can enter the parameters for the solution. And so the first thing I want to highlight in these parameters is that you need to fill in your email address or an email address where you wish to receive the alerts from the triggered events through the solution from GuardDuty. And you need to actually, once you've completed deploying the stack, you will get a subscription confirmation from Simple Notification Service. You need to confirm that so that you can receive those notifications. We also provide a parameter where you can configure the time to live. By default, we have this set to 12 hours, but you can change this to meet your own requirements. And then we have a couple of things related to the IP sets. So by default, we actually create an IP set at the CloudFront level with the WAF and also at the regional application load balancer level. So if you leave these two parameters set to false, we'll go ahead and create those. You can, however, enter an ID of your own IP sets in here, and those will be used. And then finally, the artifacts for this are essentially the deployment packages for the Lambda. Those are essentially available through the blog in the Northern Virginia region. If you wish to deploy this solution into an alternate region, you can actually change this. You'll need to upload those artifacts. And there's a little note and instructions on how to do that in the blog. Okay, so I want to highlight that I want to kind of just walk through this in the sense of a solution where we're trying to protect our public website. And so let's just say that we have this public website that you see here available, and we want to go ahead and use a web application firewall ACL. So I just wanted to demonstrate that actually I can currently freely get to this website. It's available for me, and I can refresh it. In a moment, I'm going to show you with the solution in place that it actually gets blocked. But this is kind of the demo website that we set up for the session today. Once you deploy the solution, you will have a series of outputs from CloudFormation. You'll see the create complete, and in those outputs, you'll see the Lambda functions that we create. You'll see other resources that are created as part of the CloudFormation stack and so forth. And so here's for example, our CloudFront IP set ID and ALB IP set IDs for reference. So for simulating the attack, we actually were using a couple of EC2 instances. And so the way that we have done this is to try to simulate a SSH brute force attack. So this attack is actually in a controlled environment. And as you can see, I have this red team host deployed. And this is where I'm actually simulating the SSH traffic from. So you can see that the IP address of this host ends in 86.37. And I'm going to reference that IP a couple times as we go through the demo here. But essentially, we have launched an attack that's simulating an SSH brute force using a tool that is called Crowbar. And so this actually is not a successful attack, but it essentially is going to go through and using bogus SSH keys try to go ahead and compromise or brute force into an instance. And so this is not a successful attack. This is just a simulation, but it does actually help us trigger the finding that we're looking to do to actually launch the action or launch the solution that does the mitigation. All right, so once that's done, and in this case, we actually triggered an attack earlier, and we simulated this because it does take a few minutes to actually, it takes several minutes to process and launch the finding in GuardDuty. We went ahead and did that ahead of time. And so you can see that we have in our findings here, we have a particular finding that I'm going to highlight and go into in a little more detail now. And so if I drill down into this finding, you can see that we have this IP address performing SSH brute force attacks. As Alex was mentioning, we actually enriched this information in the finding with metadata. With your permission, when you enable the service, we can actually issue describe calls and enrich these findings with metadata. In this case, you can see that we provided more details around the target, and we've also provided some information around the actor, the location. This would be the source of the attacker, or in this case, our red team instance that's out there. So once the finding is triggered in GuardDuty, that's actually going to flow through to CloudWatch events. And so now I want to touch on the CloudWatch events aspect of this solution. So within the CloudFormation template, we actually configure a CloudWatch event rule. And that rule you can see here. It's actually got an event pattern that matches on the findings that we are configuring in this blog post for the solution. So you can see we have a number of EC2 finding types that are being looked at. And when it sees one of those come in, it actually will fire this Lambda function. And so if I go ahead and click that, we can see that the Lambda function has essentially fired here. And so we'll have a history of that invocation in our monitoring for the Lambda function. And so when that Lambda function executes, it's essentially going to go ahead per the pattern we've outlined and update those ACLs. So the first one it updates is the WAF ACL that's out there. And so you can see that that IP address has actually been added here. And just to go back, we're seeing that IP address is 86.37. And so we've added that IP address here in our IP set, which is configured in this ACL as a blacklist. So we're going to be blocking that traffic. And just to demonstrate that effect, I'm going to go ahead and I'm using SSH tunneling here to push this traffic through my red team instance. And so you can see when I run that traffic for this site through my red team instance, that request is actually blocked by CloudFront, and that's because of this ACL that we've configured that was fully automated for us. So there wasn't a human didn't have to take any steps. This was actually performed through automation by the solution. And these are the types of solutions that you can build on. As I mentioned, there's a number of patterns you might use. This is just one example. There's many more that you could actually introduce in your own environments. The other part I want to highlight is, in addition to the WAF ACL, we also update a VPC network access control list. So you can see that that's actually happened here as well. So that's going to go ahead and block all traffic to that EC2 instance from this IP host. And then finally, I want to touch on Dynamo. So I did mention that we have DynamoDB. This is actually just used to store the state of the blacklist that's out there. And you can see here that we have an entry that has our stateful metadata in it. We've got the creation time, the host that's been blocked, and some other information. And this timestamp is actually used in the solution to determine when we should actually go ahead and age those entries out based on the TTL that you configure. All right, so the last thing I want to do is I want to go ahead and actually edit this blacklist to go ahead and allow that particular IP address through. So let me see if I can go ahead and delete this entry here. So I've removed that entry, and let's go ahead and see if we can refresh here. And yeah, so as you can see, removing that entry actually now allows us to access this site. And so that concludes the demo for this session. I'm going to go ahead and turn it back over to Alex, who's going to close us out.
All right, so as Cameron pointed out in the demo, this is just a pattern and example. So we'll actually provide you some additional resources, but I also wanted to give you some calls to action to help you improve your own security posture. So first one is to consider using web application firewall in your web applications. As I mentioned earlier, Mike, Cameron, and myself, we talk to our customers a lot about how to take their applications and then add additional layers of security. And AWS WAF is really a great service for that purpose. One of the things you can do with that is integrate it directly into your CI/CD pipelines, so your security protections and rules evolve just very closely with your application. As your application changes, so can your WAF rules change along with that. Another big takeaway for today, I would say, is to consider turning on GuardDuty. A lot of our customers find that GuardDuty really is a useful service that provides very quick feedback and really gives them real threats to their AWS infrastructure, and you can really quickly act on that. Turning it on is extremely simple. So you just click on that one button that I'm showing on the screen. You'll literally just a single click. And once you enable it, there is a 30-day free trial. And even during that 30-day free trial, GuardDuty will tell you how much it would have cost if it actually charged you for during that time. So you can then take those charges that you see within the first 30 days and kind of project over a longer period of time what it costs you to run GuardDuty long term. Another call to action is definitely to please check out our blog post. Like I said, this is an example. I think one you can really learn from and then extend it to your own accounts and extend it to your own custom situation that you might have in particular applications that you're developing. We are posting links to that blog post as well as to the code that goes along with the blog post that's on the GitHub. And as I mentioned earlier, a copy of the slides will be provided to all the webinar attendees. So please check the blog post and check out the code, download it and extend it for your own situation. And that concludes today's Tech Talk. Thank you very much, and we're standing by for any questions that you might have. Thank you.